Hello everyone, welcome to yet another lecture series on basics of electrical engineering. In this lecture, we are going to see superposition theorem, the theory behind superposition theorem, and few of the solved examples with respect to superposition theorem. So let's get started. So superposition theorem, any theorem for that matter will basically have a statement and it will try to convey something to us and we'll be trying to look at superposition theorem in much simplest way as far as possible. So we'll be considering a circuit and we look at the statement, try to correlate what the statement is trying to convey with respect to this circuit. So it states that in any linear network containing more than one independent sources, the resultant current in any element is the algebraic sum of the currents that would be produced by each independent source acting alone, all the other independent sources being represented meanwhile by the respective internal resistances. So the statement looks much complicated in this way, but let us try to simplify the statement. So how do we try to simplify the statement? Now if they have asked us to find current I4 through R4, so we'll be considering one source acting at a time and the other source will be represented by open circuit or short circuit depending upon the type of the source that is. So in this case, if they have asked us to find I4 through R4, we'll be considering V alone and represent current source by open circuit, and we'll be considering I alone and represent V by short circuit. So two separate cases will be considered, and the current that is found in each of these cases will be added separately. So what is superposition theorem? The superposition theorem is basically used to consider one power source at a time. So each and every source will be considered at a time, and the overall a combination of current or voltage that we are finding will be the sum of the actual values. That's it. That's as simple as it looks like. But let's consider a typical example. What if they've asked us to find current I4 with respect to R4? So before that, we'll have a common convention. Current source is represented with open circuit and voltage source is represented with respect to short circuit. The reason why it is this way is that voltage source, ideally speaking, will have zero resistance. So that's why the internal resistance with respect to voltage source will be zero. That's why it's represented as short circuit. And with respect to current source, the internal resistance will be very high and hence it is represented as open circuit. So let us simplify this. There are two sources. So we'll be considering V alone in the first step, and in the second step, we'll be considering I alone and find the current through R4. So step 1 is to consider voltage source alone and open circuit the current source. Find the current. That is what is supposed to be done. So when we are considering voltage source around, current source should be open circuit according to our convention, isn't it? So I'll be representing this way and I'll be representing it as I4 dash is represented. So how can this be? We'll be finding the value of I4 dash by using KVL or KCL or any other techniques for that matter. Again, we will in the second step we'll be considering current source alone and we'll be short circuiting the voltage source according to our convention. So current source is considered and voltage source is short circuited. So in this case we'll be finding I4 dash and I4 double dash. So finally what we'll be doing is we'll be finding the overall current, that is nothing but the sum of individual currents found out with respect to each of these sources. So that is what the statement is trying to convey. So in any linear network containing more than one independent sources, there are two sources here. The resultant current in any element is the algebraic sum of the current. So these are the algebraic sum of currents that are found and that would be produced by each independent source acting alone. All the other independent sources being represented by their respective internal resistances. Respective internal resistance is nothing but this node that is mentioned. Current source will be represented as open circuit, voltage source will be represented as short circuit. It is as simple as it looks like, isn't it? So once we are clearly aware of the steps involved in order to solve superposition theorem, they will be solving two worked examples with respect to it and each one of them are unique. So let's get started with the problems. So example one, they've given us a network and asked us to find the current flowing through 2 ohm resistor. So first step that we have to observe is that there are three sources. That means we have to consider one source at a time and there will be three steps basically in this manner, right? Considering 40-volt source. So at the first place, we'll have a convention written. Please do make a note of it somewhere. So with respect to our convention, we'll start. This is a standard uh, basically this is not a convention. This is how it is supposed to be represented, so be very careful because of their internal resistances. So we'll be considering 40-volt source acting alone. In that manner we will be representing an equivalent circuit. We'll be labeling that current as I dash with respect to 2 ohm resistor. So that is what is asked. So looking at this circuit, you can observe the 10 ohm resistor and 2 ohm resistor is connected in parallel. So using the formula for parallel resistance, you'll be simplifying this 2 into 10 by 2 plus 10, you will be getting 1.67. So the circuit can be further simplified and written in this manner, isn't it? So now I is equal to 40 by, we'll be finding the value of I. So I is equal to 40 by 5 plus 1.67, 5 ohms plus 1.67, they're connected in series. This is nothing but simple application of Ohm's law. I is equal to V by R. We'll be finding the value of current, which is equal to 6 amps in this case. The reason why we are finding I is that by current division rule we can find I dash. How can we do that? Just look at this. The current division rule, in case you have missed this video, please do watch it. It will be included in the description. So current division rule, the formula is given as Ix is equal to I into resistance of opposite branch divided by sum of resistances. So Ix, in this case, we are supposed to find current flowing through 2 ohm resistor. So it can be given as the main current, actual current, that is nothing but 6 amps into resistance of opposite branch. Resistance that is opposite to 2 ohm resistor is 10 ohms. So I've written 10 ohms divided by sum of the resistance with respect to the two resistances that are there, in this case the opposite branch and the actual one. So 10 plus 2 ohms, you'll be getting 5 amps. So this is one important observation. This is one important result that we have got. So from here we'll be considering our second step. Again, I've made a note of this note throughout so that you will not go wrong with respect to the application of steps. So step 2 is to consider 20-volt source alone. The reason why current is considered in this direction is because the supply will the volt current always flows from negative to positive with respect to the convention that we have taken. So in this case we'll be writing the current. So since current flows in this direction, this is also conventionally taken as I double dash in that case. So be very careful with this step. So we'll be further simplifying this. Again, 2 ohms and 10 ohms are connected in parallel. The voltage source are represented as short circuit in this manner. So we'll be getting the value of the resistance as 1.67. You can see 5 ohm and 1.67 is connected in series. The value of I can be simply found out directly. Before that, you will be finding I is equal to 20 by 5 plus 1.67, that is equal to 3 amps. So the value of I is given by Ohm's law, that is V by R. This is the formula that is used for finding the resistance of the opposite branch in the current divider rule. So now next step is to find the current flowing through the resistance 2 ohms, which is being given by current division rule. So the main current is 3 amps into the current flowing through the opposite branch, which is 10 ohms in this case, divided by 10 plus 2 ohms. That is the correct the overall value of the resistance that is considered with respect to 2 ohms and 10 ohms. You'll be getting 2.5 amps in this case. So this is an important result. Again, we have made a note of this important observation. So step 3, when the 10-volt source is acting alone, so the effective combination of the representation of the network looks like this. The voltage source is short circuited and it is represented in this manner. Since the voltage source is in the opposite, in the inverted direction, so the current will be flowing in that direction. So we have considered I triple dash in this direction. So be very careful with the convention in which the current is taken. RP is equal to R1 R2 by R1 plus R2. We have simplified 5 ohm and 10 ohm that are connected in series, and we'll be getting 3.33 ohms. Now we'll be applying Ohm's law. You'll be getting I triple dash as 10 by 3.33 plus 2. This I triple dash will be directly obtained, not in the case in which we have to apply current division and all, because in this circuit it's very straightforward. We'll be able to get I triple dash in this way. So once this is done by superposition theorem, the resultant current is nothing but the sum of individual currents, isn't it? So I is equal to I dash plus I double dash plus I triple dash. You will be getting the value of the current to be 4.38 amps. This is the current flowing through 2 ohm resistor. So this can be done in different ways. You can use KVL and KCL. If they have specifically asked you to find out using superposition theorem, this can be used. So we'll be looking into our next problem. Find the current flowing through 4 ohm resistor. So usually, why is superposition theorem generally used? Because the number of steps involved is also very high, isn't it? But circuits like this, if the complexity of the circuit is very much larger and there are more than 4 to 5 sources, it's very difficult to keep a track of applying KVL and KCL and finding out and solving 5 different equations altogether. In that case, you can consider one source at a time and find the value. That's why it's actually being used popularly. So step 1 is to find the value of current current flowing through 4 ohm resistor considering a current source of 5 amps acting alone. So we will be representing the current source, and the voltage source is short circuited over here. So now we will start looking at the circuit. Looking at the circuit, this gives you a picture that 5 ohm and 6 ohm are connected in parallel because they are connected between the same 2 points. So can we write Rp is equal to 5 into 6 by 5 plus 6? You will be getting 2.73 ohms. Now we'll represent that in an equivalent form. So this is the equivalent circuit. So simplifying these two resistance, you will be getting 2.73 amps or 73 ohms. So in this way, these two resistance are connected in series. We'll be adding them up, and we will be representing them in this way, 8.73 ohms. Now they have asked us to find the current flowing through 4 ohm resistor, that is I dash. So how do we find that? We can simply find it by applying current division rule, because 5 amps is already flowing this circuit, so we know the main current flowing through this branch. So that means we can find the value of I dash directly. So I dash is equal to 5, that is the actual value of current, into the resistance of the opposite branch. Since we are finding it for 4 ohm, the resistance opposite to 4 ohm resistor is 8.73 ohms. So 8.73 divided by 8.73 plus 4 ohms, this is the sum of resistances that we are considering. So 3.43 amps is the current that we are getting. So this is our first step, and this is our first result. Again, similarly, we'll be considering 20 volt source acting alone. Since current source should be represented as open circuit, we will be representing it as open circuit, and we have to find the current flowing through 4 ohm resistor. So looking at the circuit, our first observation will be that the currents 2 ohm resistor is actually in open circuit condition, so its value will not be effective because the no current flows through 2 ohm resistor. Whenever current doesn't flow through a particular circuit, there is no effect of that particular component in the circuit. So in that way, we will be having current I double dash flowing through this branch. That means 6 ohm and 4 ohm are connected in series. Looking at this, because this is open circuit, so you will be getting 10 ohms over here. 6 ohms is again represented in its normal way. 5 ohm is kept as it is. 20 volt is kept as it is. Now we have to find the value of I double dash. So we will be starting off by simplifying the effective resistance that is connected in parallel over here. 6 ohm and 10 ohm is connected in parallel. Simplifying it, you will be getting 3.75 ohms. Now we'll find the value of I by applying Ohm's law, that is I is equal to V by R, that is 20 volt divided by 5 plus 3.75 ohms. You'll be getting 2.29 amps. Again, we'll be finding the value of I double dash by using current division rule, that is the main current into the current in the opposite branch divided by the sum of resistances. You will be getting 0.86 amps. So once we have both these currents by superposition theorem, we know that I is equal to I dash plus I double dash. We'll be adding the current that is obtained in the previous case and the current that is obtained in this case. You'll be getting 4.29 amps. So this is it. This basically covers some of the important problems with respect to superposition theorem. If you have any questions, please feel free to reach out to me by typing in your questions in the comment section below. If you like this video, please do like it and share it to maximum number of people for them to learn these concepts in a much better way. Thanks for watching this video.